if we're happy, we will kick off with the first session, which is Resilience Engineering Synergy with Threat and Error Management, an operationalized model. And this is Andrew, my colleague, who will be presenting that. And this is something that we both worked on. So Andrew, whenever you're ready, please.
Cool, thanks, Pete. Thank you very much. Let me just share my slides over with you, and hopefully you're seeing this successfully now with the title screen of the presentation. Good nod, thanks, Pete. My name's Andrew Mizzi. I'm a PhD candidate at Griffith University, where I'm speaking to you from today, as well as being a 747 pilot at Cathay Pacific, where I work with Pete. We worked on this paper together. Pete's the group human factors manager at Cathay Pacific and also PhD candidate at Cranfield University. And this paper's especially come out of some work that we've done at Cathay Pacific in creating a new briefing model, operationalized model, which through its development found a lot of synergy and correlation between threat and error management that we were tying into the model, with also meeting some objectives around resilience engineering as well. Upwards every day, hundreds of thousands of flights take off around the world, carrying passengers and cargo to their destination, and sort of found two examples demonstrated through these charts of how safety in aviation has improved over the last 60 years. And predominantly, this has been driven through technological advancement. So you can see on the left-hand a bar chart or column chart, you can see how the safety has improved in a decrease in fatal accidents versus the number of flights in per million that have increased in this this divergent correlation between safety and the number of flights and how safe we're getting. Whereas on the right-hand side, that chart's showing the 4 different generations of aircraft and how that has contributed to the fatal accident rate. So those early aircraft, early jets, we're going back and thinking about aircraft like the Comet and the 707 aircraft back in the 1960s and 1970s, had quite a high fatal accident rate. And then further generations of those aircraft, like in generation 2, the Concorde, early 747, 737s and DC-9, DC-10 had a significantly lower accident rate. But to a very large extent, it was the generation 3 and generation 4 aircraft, like the later 737, 767, 757 models, and then leading into the fly-by-wire aircraft like the A320 series, A330s, and so forth, Boeing's 777s. A lot of that development from the 1990s onwards was actually driven not through technological advancements, because they actually started out to be very safe in the first place, but a lot of that focus was around CRM and threat and error management. And that leads us into the problem, the paradox that we have now, in that in an ultra-safe industry, how do we find these continual improvements to safety? And for aviation, a very large amount of that in safety science has been a reliance through high reliability organizations, and particularly nowadays through sensitivity to operations, what we call safety 2, but also a constant preoccupation with failure, commitment to resilience and deference to expertise. But then also through concepts like threat and error management. The problem that we find with threat and error management, to a large extent in the way that it's implemented in airlines, is that it focuses on the prevention of undesirable outcomes. Whereas resilience's focus is on the reinforcement of success. And there's also quite a dichotomy between those two focuses, but then also quite a lot of commonality and synergy between those two concepts of threat and error management and resilience engineering as well. So when we're looking at the research, one of the things that I've just quickly done here is to have a look at how the research has been developed over the last 20 years or so, since early 2000, both in crew resource management, and threat and error management. So, for instance, in the top left-hand corner, is the development of research into CRM. You can sort of see from the early 1980s, there's been a gradual and constant increase in the amount of research output into crew resource management. But as we can see in the threat and error management research output, measured in documents per year, sort of in the main line chart that's on this slide. From early 2000, there's been a slight increase, but generally we're only looking at perhaps maybe 5 papers per year. So there's really only a small research output in threat and error management. It's quite an under researched discipline. And certainly, as we can see, the relationship between threat and error management and resilience, when I did a quick search on Scopus, there was only 3 results in Scopus compared to 881 when we looked at crew resource management, and 57 in threat and error management. So there's still a lot of research space in the paradigm of threat and error management that can be done, and certainly between the two, threat and error management and resilience engineering. So today's presentation, we'll first look at threat and error management, and we'll look at resilience and its capacity and offering into safety. We'll look at the synergistic properties between the two, how it can be applied in practice for airlines, and then the conclusion and some questions if there are any. So threat and error management is an active safety approach. It's widely utilized in aviation. It's founded on the understanding that threats and errors, they're inevitable during flights, and it emphasizes a need to detect and correct them before they escalate into incidents or accidents. It's a framework, the threat and error management framework, encourages crew to proactively identify threats to flight safety and implement strategies to mitigate those threats. And failure to manage or address those threats can then lead to errors that require detection and proper management. If those errors go unchecked, then they can lead to undesired aircraft states, and then that can lead to an accident or incident. Aviation employs various strategies to manage threats and errors, including proactive measures like mitigating anticipated threats like adverse weather, using checklists and standard operating procedures to address what we call latent threats, automation to reduce pilot workload, executing go-arounds, diversions where necessary, their recovery actions. By implementing those strategies, the risk of accidents can be reduced, and that overall enhances aviation safety. The problem with threat and error management is confusion around how to integrate threat and error management into CRM training. It's argued that there's no standalone implementation of threat and error management in airline training, apart from acknowledging its key concepts of threats, errors, and its outcomes. But despite this, the Line Oriented Safety Audit program, LOSA, which was developed in conjunction with threat and error management, it provides a systematic observation tool for airlines, even though there's still some mismatching in the training that airlines do in threat and error management. So the LOSA methodology examines flight crew threat and error management actions during normal line operations, and it has been really successful and is recognized as a proactive measure in flight safety. But it's also important to acknowledge that the focus of threat and error management principles is based on an error management model that also doesn't fully consider the complexity of systems involved in its application. Get the next slide. There we go. So the objective of resilience engineering in that case then is to design systems that can swiftly adapt and recover to unforeseen challenges or failures. So resilience is achieved when the system, comprising of the flight crew, the aircraft state, sustains its necessary operation under expected and unexpected conditions. Resilience engineering is founded through 3 principles. 3 fundamental values, I guess you'd say. They're finding resilience, assessing resilience, and creating resilience. And creating resilience has remained an essential aspect of resilience engineering, emphasizing these operationalization of capacities that emerge from resilient work. The first capacity that resilience engineering talks about, that we can see in the diagram, is anticipating and preparing for potential failure. So it necessitates maintaining a vigilant focus to identify and evaluate potential threats, and also devise strategies to mitigate or prevent their occurrence. The next capacity involves monitoring indications of system degradation to adapt and recover to failures when they do happen. And this requires implementing systems and processes to swiftly identify and respond to failures, as well as having the availability of resources and capabilities to address those compromised systems and recover from undesired aircraft states. And the need for team training and resilience is also emerging in aviation, not only just threat area management, CRM, resilience as well. So we've recently seen EASA, the European Aviation Safety Agency, revising its regulatory framework for crew resource management to include resilience development. It's been argued that that normative language, in the same way that we've seen perhaps occur with CRM, lead to that training categorization actually becoming a level of accountability as well. That language can place responsibility on the pilots for not being resilient, or not just dealing with the system performance, but also belief around how resilient theory should be used. So it's because of that, and the way that we've seen CRM used as well, certainly in terms of accountability, when we read accident reports, it's crucial for airlines to thoughtfully and ethically incorporate resilience deep into their training, their policies and procedures, and making sure that regulators then also adhere to ICAO guidance on human performance. So threat area management contributes significantly to resilience by prioritizing the proactive identification and assessment of potential threats, and those actions level the crew's ability to learn and anticipate two of the resilient capacities. Through early identification and anticipation of potential threats, strategies can be implemented to mitigate or prevent their occurrence. This proactive approach expands the crew's capacity and acceptable boundaries for handling flight disturbances, and therefore enhances the overall resilience of the system. And additionally, threat and error management also strengthens resilience by emphasizing error monitoring or detection and correction. So by implementing effective processes for promptly identifying, rectifying errors, it becomes possible to prevent these errors from escalating into more severe events by responding to them, or by responding to those undesired aircraft states. And this ensures that any disturbances to the flight that occur are swiftly recovered, and it returns the crew back into their established norm of operating. So in this paper, we've proposed a method that airlines can adopt both in their training and also operationalising in their SOP to introduce those resilient principles through the flight crew briefing that Pete and I worked on developing. The briefing model that we designed combines threat and error management with the necessary components for resilience, and it was developed firstly to meet the needs of an airline in enhancing our crew briefings, and especially after we found this synergy between threat and error management and resilience engineering. So the model that we developed is called the STC briefing. It's constructed of 4 modules in a structured chronological format, with the briefing roles recommended to be shared between pilot flying and pilot monitoring. It's designed to identify threats first and foster crew communication through a framework of briefing and overview, initially of where we are or where they are. And let me get my laser pointer out. This one here, the situation where we are. And then a more detailed briefing of what our plan is, how we'll execute the plan, and then lastly, what we'll do if that plan doesn't work. The briefing should aim to prime crew to anticipate, monitor, and respond to those resilient potentials to threats, errors encountered in flight operations. And the briefing should establish boundaries of operating around what's anticipated parameters of how threats will influence those boundaries. and actions to recover from errors that approach those boundaries. So as you can see in this Venn diagram, there's 3 core modules of the STC brief, but they don't actually align with 3 resilient potentials of anticipating, monitoring, and responding. Instead, there's an overlap between them and between those 4 modules. So during the crew briefing process, the crew anticipates threats and strategizes them using the strategic plan, which establishes monitoring cues and boundaries, both through the strategic and tactical plans. And then this enhances the crew's ability to respond through the tactical and contingency plan. The interaction between those modules facilitates an improved conversational flow, and that in itself also reinforces those resilient potentials. So to summarize, the future of resilience engineering in aviation is really strong. We've got supranational regulators such as EASA that are implementing early editions of the regulation requiring training into resilience, and future evolutions of this regulation, plus from other regulators, are anticipated. The emphasis on human factors in threat and error management significantly contributes to system resilience by training and assisting crew members in effectively anticipating, monitoring and responding to threats and errors. Threat and error management aligns with the potentials of resilience, leading to enhanced overall performance and decision-making abilities of the flight crew. So this improved performance becomes crucial in responding to undesired aircraft states, ensuring that timely crew actions and corrective actions achieve negligible consequences and minimize their impact during recovery. So it's recommended that regulators and airlines further develop and integrate threat and error management and resilient concepts, while also encourage the maturity and widespread use of Safety Audit programs. Thanks very much. We'll see if there's any questions.
Perfect. And thank you, Andrew, for that very clear and very enlightening presentation. And I'll quickly see if we've got any hands up anywhere or any questions on the chat. I can't see any just now, but I have got one, as I always will. I mean, I've followed you through the process with this, and we've worked on this together. And one of the things that struck me when we first looked at this was, in almost part of the literature review, was trying to understand the effect that non-technical skills, so CRM training, had in the early days. And that then was built upon when we think about threat and error management and LOSA. So it's almost like ages of development. So the 70s and 80s with your CRM and non-technical skills, into the 90s and early 2000s with threat and error management and LOSA. And now we start to see this emergence of resilience and adaptive capacity. Do you see this as almost the new age of safety and performance?
Yes, absolutely. And we're seeing this replicated through other audit systems as well. You know, sort of we've had a really good run with LOSA, and we're seeing LOSA also having to continue to develop as well into looking for resilience that occurs amongst systems as well. And then applications such as the operational learning review, learning information teams, learning teams, which is taking the opportunity to improve safety within airline systems and airline crews. So moving towards improved resilience in flight operations and flight safety, I think absolutely is the next generation of where flight safety is moving to. And then coupled within that is then the way that airlines can go and measure and audit the success and the efficacy of that work and those systems that they're putting into place.
And do you see, we see that there's this move from the operators. Do we think that the manufacturers will follow suit, maybe, with some of the technical instructions they put out?
Yeah, absolutely. And like all evolution of anything new, it generally comes from those that are on the ground and working on it at the moment, working on it every day. So as always, airlines always sort of outpace how quickly regulators can move, and to an extent as well, airlines are also going to a small extent compared to regulators, outpace what the manufacturers are doing. But there's certainly interest amongst manufacturers to leverage this as well, and we'll certainly see an increase in that happening as the resilience engineering discipline, for instance, continues to mature as well. Sort of seeing continued interest across all stakeholders in flight safety.
Perfect. Thank you very much. Thank you, Andrew. I can't see any other questions for now, but I'm sure we'll start to see some being populated in the chat.